Hi, I'm John Ackermann, N8UR, and I'd like to introduce you to the TASS RF switch. It's a project I've been working on for the last few months, and that Tapper is now going to offer as a kit. As part of my time and frequency experiments, I measure multiple sources such as frequency standards or clock outputs with the counter and log the data to disk. I want to use a computer to automatically switch from one signal to another for each round of measurements. Sometimes I'm testing a batch of 4 or 5 devices against 3 or 4 reference signals, so I need multiple switches, each with a bunch of ports. In the past, I used some surplus HP switches, and they worked really well, but those switches are now several decades old and are starting to fail. I found that you just can't get replacement parts, so I decided to design a more modern switch system using a combination of a relay board and a small processor, such as an Arduino, to provide the logic. The TASS is the result. We think it is useful not only in a laboratory, but also in a ham shack or wherever you want to route multiple RF or audio signals between sources. The TASS relay board has 8 BNC connectors and it's 2.2 by 4.4 inches in size. It'll mount into a 2U rack panel. The connectors are arranged in 2 groups of 4. Each group has a common bus. Between each connector and the bus is a relay. Pins on a 10-pin header control a set of relay drivers. A 2 to 5 volt signal on a pin turns on its associated relay. The switch is designed to operate from DC to 150 MHz with low insertion loss and a good SWR. We paid a lot of attention in the design to high isolation between the ports, so crosstalk is minimized. The board is designed to handle about 10 watts of RF power. It's not intended to follow a big amplifier. The TASS-R uses 12 volts DC at from 15 to 150 milliamps, depending on how many relays are energized. Because the TASS relay board does not have any intelligence, it needs an external controller. Any simple microcontroller will work, a PIC chip, AVR, Arduino, Raspberry Pi, whatever, as long as it provides at least 9 digital output lines. We decided to use the Arduino, and I designed a daughter board, or shield in Arduino speak, that will support up to 4 TASS relay boards simultaneously. We cleverly call this the TASS shield. It mounts onto an Arduino Mega 2560 processor. We use that version because it has enough I/O pins to control 4 boards, with pins left over for other uses. The TASS software was written in the Arduino development environment. It's open source, free to download, modify, and use however you'd like, and currently it provides USB and Ethernet connections to a host computer. The commands are simple ASCII strings. Just for fun, we also created a touchscreen interface. It uses a simple TFT screen that's available from Adafruit for about $45, and creates a fully functional standalone system, although it's not quite as flexible as using the PC-hosted commands. Here's a screenshot of a terminal program on my PC talking to an Arduino that's running the TASS controller software. The commands are 3 ASCII characters, surrounded by left and right arrow characters as delimiters. The first character selects the board, the second character selects the relay, and the third character is the command. The H or hold command will turn a relay on and keep it on until it's explicitly turned off. Typically, you use the H command to set the common port on a bus. The S or set command will turn a relay on, but will reset that relay when another S command is issued. This allows you to toggle between relays with only a single command. The U or unhold command will turn off a relay that's been either set or held. If you select relay 0, that will clear all the relays on the board, turning everything off. Here's a bare-bones schematic of the TASS relay board. You can see how the connectors are grouped into 2 buses. By selecting relays, you can route, for example, the signal at port 1 to port 3, or the signal at port 5 to port 8. Each relay is controlled separately, so you can turn on any combination of the 8 ports. This provides great flexibility and allows for many different configurations. The relay board also has pads that allow you to extend each of the 2 buses. These could be used, for example, to put an external common connection for each bus on a panel. That allows you to have 4 switched ports in each group. These connection points can also be used for other purposes, as I'll describe a bit later. 3 or 4 ports often aren't as many as we would like to have in a switching system, so the TASS-R board is designed to allow all the ports to be routed to a single external common connector, making it a true 8-way switch. This is done through an additional relay that toggles the external connector between the 2 buses. The TASS software can automatically switch this relay based on the port number entered in a command, so the PC program doesn't have to do any extra work. This drawing shows perhaps the simplest configuration for the TASS relay board. There are 2 independent 3-way switches allowing, for example, 2 radios to each connect to one of 3 antennas. This configuration doesn't use any external connections at all. This is an example showing how the toggle relay can be used to create an 8-pole switch. Because the 2 sets of connectors and relays on the TASS-R board operate independently, we can configure them to act as a double-pole switch with the ports on both buses switched simultaneously. This functionality is programmed into the TASS controller software. Here's an example showing how that capability could be used to put bandpass filters between an antenna and a receiver. The extension ports on each of the buses can also be used to daisy chain ports together to create even larger switches. In this example, the buses of 2 boards are connected together. The controller software is configured to assume each bus has 8 ports. Using the toggle relay to select the bus as before creates a 16-port switch. There's no reason 3 or even 4 boards couldn't be connected this way. However, each board extends the signal path and will reduce performance at VHF frequencies. As you've seen, the TASS relay system is a very flexible and expandable solution for routing signals around a ham shack or laboratory. The TASS boards are now available from Tapper as kits, and you can order them at the URL shown here. The TASS-R kit is $119, and the TASS Shield kit is $19. Remember, you'll need to get the Arduino yourself. Both the TASS relay board and the TASS Shield use through-hole components, and they don't require any special assembly techniques. The Arduino software and other documentation are also available from Tapper at the second URL shown. Again, the software is open source, free for you to modify and use as you see fit. If you have any questions about the TASS system, please contact me at the email address shown here. I hope you'll find the TASS relay system to be as useful as I have. Thanks for taking the time to view this video.